Okay, let's look at the homework 3.7, problem number 4. Right? So we want to find the area of the largest rectangle inscribed in the ellipse x squared over a squared plus at y squared over b squared equals 1. Right? So let's do that. Alright, so I already drew a picture. Alright, so I'm gonna call this point on the ellipse x comma y. Right? Since ellipse of the equation of the ellipse is given here, I'm going to solve this for y. Right? So this is going to be equal to, going to subtract x squared over a squared. Right? That will get us y squared over b squared is equal to 1 minus x squared minus over a squared. Right, then multiply both sides by b squared. We get y squared is equal to b squared times 1 minus x squared over a squared. Right, then we can just take the square root of both sides. So y is going to be equal to plus or minus, right, square root of b squared would be b, and then you have a square root of 1 minus x squared over a squared. Right, so which means that at this point, instead of using the two variables, we can use only one variable. So x and y can be written as this is on the top, top half. So it's a plus b square root of 1 minus x squared over a squared. All right, so if you want to find the area, we can see that here. The length here is twice as much as x, so this is 2x, right? And length here is twice as much as this guy, so it's 2 times b square root of 1 minus x squared over a squared. Right? So if you want to find the area, all you really have to do is base times height. So a of x is equal to, right, so it's a 2x times that, so it's a 2 times 2 is 4. Then there's a b and the x. Then you have a square root of 1 minus x squared over a squared. Right? So this is the area function, and we want to maximize this and over interval. All right, so this vertex, it can move from, let's say, x is 0 to, in this case, let's say a. So it's x can go from 0 to a. Because I forgot to write it. So this is a here, this is negative a here, this is negative b there, and that's positive b up there. Right? So we have that. Right, so let's take the derivative to find a critical number. A prime of x is equal to, I don't like the way there's a square root, so I'm going to rewrite it as 4bx quantity 1 minus x squared over a squared raised to the 1/2 power. Right, so 4b is just a constant, and put it outside. And to take the derivative of the first guy, so we have to use the product rule. So this is our first guy, this is the second guy. Right, derivative first is 1 times the second, so 1 minus x squared over a squared to the 1/2 power, plus x times derivative of the second. So put 1/2 in front, keep the same inside the function as it is, subtract 1 from the power, so negative 1/2 power, multiply by derivative inside, which is negative 2x over a squared. All right, let's clean this up a little bit. So you have a 2 on the bottom and 2 on top. You can definitely cancel that. And other than that, we can't do too much, so I'm going to just say 4b is just outside. Then you would have, so this is just a square root of 1 minus x squared over a squared, right? So here you have a minus sign, so maybe I'll take care of that. And there's a negative sign. And then you have x squared. So you have x squared on top, right? There's a squared here. So we put a squared on the bottom. And here's a negative power. Oops. Here's a negative power. So we can put this guy on the bottom. So 1 minus x squared over a squared. And there's a square root. So that's a square root. So you have square root here. All right. So we can take the common denominator. So we have 4b is outside. Common denominator, common denominator would be a squared, square root of 1 minus x squared over a squared. Alright, so if you multiply by a squared, square root of 1 minus a squared would be a times 1 would be a squared minus x squared. Then you have another x squared, so it's 2x squared. Alright, so we set this guy equal to 0, which means that we know that, let's see, a squared minus 2x squared has to be equal to 0. Right, then you can subtract a squared. So you have negative 2x squared is equal to negative a squared. Then we can divide through by negative 2. So x squared is equal to a squared over 2. Then take the square root of both sides. So x is going to be plus or minus. Square root of a squared would be a. Square root of 2 is square root of 2. Alright, so we have that. Then what we can do is we have a critical number here. And since x only goes from 0 to a, so we only consider the positive one. Alright, then we want to make sure that this is going to give you actually the maximum. So what you can do is just, since you have endpoints and a critical number, so check all of them. So how about a of 0? Right? A of 0 would be, if you put 0, so that would be 0. Right? Then how about a of a? But if you plug in a here, so you have 1 minus a squared over a squared, so that's 0. So the area is going to be 0. So how about the critical number? In this case, a squared over square root of 2. Right? Let's plug in 4b times a over square root of 2 and square root 1 minus, right, x squared would be a squared over 2. So a squared over 2, then you have to divide by a squared. So we can cancel a squared. So it's a 1 minus 1/2 is square root of 1/2. So this is going to be 4b a over, right, square root of 2 times square root of 2, so it's 2. So we can cancel 2 and 4. And we end up getting 2 times AB, right? So we know that this is going to be the absolute maximum, right? So let's type it in. Right, the answer is actually we already have it, 2AB. Then check the answer. Alright, looks like we got this one correctly. Alright, that's it. I hope that this was clear.